The Mason-Elin Model 8012 is an electro-pneumatic valve positioner. It provides an accurate means of obtaining a valve stem position proportional to a 4 to 20 milliamp DC input signal. Besides the 4 to 20 milliamp input range, it is also available for input ranges of 10 to 50 milliamps and 1 to 5 milliamps. The current input produces a pneumatic output which positions the valve stem. The positioner is a force balance electro-pneumatic device that may have either direct or reverse action and provides a convenient means of split ranging the controller output signal. The basic 8012 positioner is used with either direct or reverse-acting spring-opposed diaphragm actuators. A stroke adjustment in the back of the case allows for valve stem travel from 3/8 of an inch to 4 inches. Other models are available for specific valves. These positioners utilize a cam feedback mechanism which provides for different control characteristics, such as linear and percentage control. In the case of the CamFlex 2 and the Sigma F, the cam also provides for split range control. The cam feedback mechanism replaces the stroke adjustment lever on these models. For a direct acting positioner, an increase in the input current causes an increase in the output pneumatic signal to the actuator. From this schematic, we see as the current increases to the force coil, the right end of the beam moves down. The left end of the beam moves up toward the nozzle. As the flapper covers the nozzle, the relay output starts increasing. The increasing air pressure to the actuator moves the stem down on this direct-acting actuator. The resultant valve stem movement is transmitted to the force balance spring, extending the spring until the force exerted on the beam balances the opposing force of the coil. As the two forces equalize, the nozzle back pressure decreases. The system then is in equilibrium, and the positioner output is stabilized at an amount necessary to maintain the desired control valve plug position. Here are the actual parts: the force coil, the force balance spring, the beam and flapper, the nozzle, and the relay. The metering tube, or orifice for the nozzle air supply, is furnished with a clean-out plunger which forces a small wire through the orifice. Now work exercise 7 in your workbook. On control loops that are not intrinsically safe, de-energize the circuit before removing the cover. It may also be necessary to get a hot work permit. The cover and conduit must be tight for the positioner to be explosion-proof. But the positioner is intrinsically safe when the barriers or converters of a control system maintain the energy to the positioner at such a low level that ignition of the hazardous atmosphere is impossible. The positioner is mounted on the actuator by means of a mounting plate. The mounting plate is attached to the positioner with 3 screws. The mounting plate is fastened to the pad on the actuator spring barrel with 2 cap screws. On direct actuators, the positioner is mounted to the left of the actuator stem. To mount the positioner on a reverse-acting actuator, the mounting plate, the cover plate for the stroke adjustment, and the back lever must be turned over. Then the positioner is mounted to the right of the actuator stem. After the positioner has been mounted, attach the takeoff clamp to the actuator stem at a point which permits full actuator stem travel. The turnbuckle is installed in a vertical position between the stem clamp and the back lever clevis. The lower end of the turnbuckle hex has been machined round to identify the right-hand thread, which engages the turnbuckle screw. Larger actuators require a longer turnbuckle and stem clamp rod. Connect a regulated air supply to the 1/4-inch connection on the relay marked N. Connect the valve actuator to the 1/4-inch connection on the relay marked Out. To calibrate the positioner, the valve travel must be known. Loosen the index lock screw and rotate the pinion until the stroke index is opposite the marking on the stroke scale corresponding to the rated stroke of the valve. With no pressure on the actuator, adjust the screw on the spring lever until at the short end of its stroke, the force balance spring will have a slight tension. Tighten the nuts on the tension adjustment. Turn on the air and set the air supply regulator for 20 psi for a 3 to 15 psi actuator. Adjust the input current for midpoint of the positioner input signal range, 12 milliamps for the 4 to 20 milliamp range. Adjust the biasing spring until the back lever is perpendicular to the side of the case. Rotate the turnbuckle until the valve is at mid-stroke and recheck the position of the back lever. Continue to make biasing spring and turnbuckle adjustments until the back lever is perpendicular to the side of the case and the valve stroke is at mid-travel. Set the current for minimum input signal range, 4 milliamps in this case, and observe the valve position as indicated on the valve travel plate. Change the current to maximum input signal, 20 milliamps, and check the valve stem travel. If the valve stem travel is more than the rated stroke, loosen the adjusting screw lock nut and turn the force balance spring adjustment screw clockwise. If the valve stem travel is less than the rated stroke, turn the adjustment screw counterclockwise until the valve stroke matches signal span. Tighten the adjustment screw lock nut. Set the input to 12 milliamps again and check to make certain the back lever is still perpendicular to the case and the valve is at mid-travel. If they are not, make the biasing spring and turnbuckle adjustments again. Split ranging the positioner is a similar procedure, except the stroke index is set to twice the valve travel, or a 1/2 standard rate force balance spring is used. And the minimum, mid-travel, and maximum current inputs would be different for the split-ranged positioner. Reversing the positioner action is accomplished by switching the position of the instrument signal leads and recalibrating the positioner. Now work Exercise 8 in your workbook. Become familiar with the instruction manual. It also has a maintenance section and a troubleshooting section. In the event of faulty operation of the positioner, always check the obvious. Make sure the positioner has the proper air supply. Be sure the positioner is receiving the correct input signal. Check to be sure the positioner is installed correctly, and look for broken tubing or loose parts. If the positioner is on a Camflex 2 or Sigma F actuator, be sure the proper cam lobe is being used. Determine if the trouble is pneumatic or electrical. To check the operation of the pneumatic circuit, pull the flapper away from the nozzle and the output should go to about 0 psi. This should cause the valve to go to minimum stroke. Exert sufficient force on the flapper to cover the nozzle. The output should be near the supply pressure and the valve stem should travel its full stroke. If the response is other than this, a pneumatic problem exists. Push the clean-out plunge of the metering orifice to be sure the orifice is not plugged. Check to see if the metering orifice body is properly seated in the relay. Check for a plugged nozzle. To remove the nozzle, remove the flapper, unscrew the nozzle and clean it with solvent and clean dry air. If difficulty still persists, replace the relay with a known good one. Or disassemble and clean the relay. If the pneumatic section is functioning properly, the electrical section can be checked with an ohm meter. Disconnect the controller leads from the positioner and connect the ohm meter to the positioner. The resistance for the 4 to 20 milliamp positioner should be approximately 173 ohms. If the resistance is not approximately correct, the trouble could be the terminal board or the force coil. To determine which is the trouble, disconnect the positive coil lead from the terminal board and measure the resistance of the coil. The resistance of the coil to the coil stop screw should also be measured. Replace the force coil if this reading indicates a value other than infinite resistance. Refer to the instruction manual for terminal board and coil replacement. Coil replacement requires special alignment rods to center the coil and align the beam. Now work Exercise 9 in your workbook.